somebody brought up this problem for it to be solved using first principle. So, but I thought it would be wise a video is used for proper understanding of the solution. Okay, now f of x is equal to 1 over square root of x plus 1. If you want to use first principle, our f prime of x equals the limit of f of x plus h minus f of h over h. Our h is tending to 0. That's the limit we use to evaluate any function from the first principle. So whenever we see x here, we are going to plug in this value here. So f prime of x equals the limit of 1 over square root of, we have x plus 1, then plus h minus f of h will give us 1 over square root of x plus 1 over h again. You have h, then h is tending to 0. Okay, so f prime of x equals, we simplify this using the knowledge of fractions. The LCM will be square root of x plus 1 plus h multiplying the square root of x plus 1. This h can be called, I can change the division to times and turn this upside down. So it's going to be 1 over h. So this divide this will give us square root of x plus 1 times 1. We have square root of x plus 1. This divide this will give us square root of x plus 1 plus h times 1. We have square root of x plus 1 plus h. Okay, so finally we arrive at f prime of x equals square root of x plus 1 minus square root of x plus 1 plus h into, this h can come in here, we have h into square root of x plus 1 plus h into square root of x plus 1. Okay, now remember we're having limits here. Let's not forget limit where h is tending to 0, the limit where h is tending to 0. Now if you try to put in 0 here for h, you see that this function becomes undefined. Therefore we have to ponder over the next thing to do to ensure we tackle this. Hence we can employ the knowledge of conjugate of surd. If I rationalize this to make the denominator rational, I'm going to multiply both sides, both numerator and denominator, by the conjugate of this fraction here. So I have that f prime of x is equivalent to the limit of h tending to 0. So I have x plus 1 minus x plus 1 plus h over h into square root of x plus 1 plus h into square root of x plus 1 multiplying, I'll change this to plus square root of x plus 1 plus square root of x plus 1 plus h over square root of x plus 1 plus square root of x plus 1 plus h. Okay, so let me clean up here to continue. Okay, from this point here, we'll continue up here. This times this. Remember, in surd, when you have square root of 3 multiplying square root of 3, 3 times 3 is 9, and square root of 9 will give you 3. So when the same thing is times the same thing, it gives you the number inside. Therefore, when this is times this, we shall get just f prime of x equals the limit of h tending to 0. This time this is giving us just x plus 1. Now, if you know difference of two squares very well, you see that this is minus, this is plus, so it's difference of two squares. After the expansion, you don't need the content at the center. Just square this minus the square of this. It's a difference of two squares. Instead of wasting your time to expand the bracket, just square this minus the other 10 squared. That's the difference of two squares. So, and when I square this, I will just get x plus 1 plus h. That's what I will get here. Difference of two squares. When you have a squared minus b squared, you have a minus b into a plus b. It's as simple as that. So you square the first one minus square the second one. So don't waste your time expanding the bracket when you see such in an examination. Over down here, this will times this. Okay, so now how do we expand this one here? Remember, this is plus. At this juncture, let's still not expand. Let's write out everything we're having there. We'll have h into square root of x plus 1 plus h, multiplying square root of x plus 1. Still multiplying another thing here, square root of x plus 1 plus square root of x plus 1 plus h. Okay, now simplifying the numerator, we have f prime of x equals the limit of h tending to 0 into, this is x plus 1, minus affecting everything here, minus x, minus 1, minus h, over h into square root of x plus 1 plus h into square root of x plus 1, multiplying square root of x plus 1 plus square root of x plus 1 plus h. That's what you're having there. Now, f prime of x equals x minus x is 0, 1 minus 1 is 0, so we're left with minus h at the top. So have lim of minus h over h into square root of x plus 1, okay, plus h into square root of x plus 1, multiplying square root of x plus 1 plus square root of x plus 1 plus h. And this we cancel out to have minus 1 up here. So anywhere I see h is tending to 0. Anywhere I see h, I plug in 0. So f prime of x equals the limit of, no limit again because I've started taking the limit, minus 1 over, if I put 0 here, I'll have square root of x plus 1, multiplying square root of x plus 1 into square root of x plus 1 plus, if I put 0 here, 0 we go, I have square root of x plus 1. So f prime of x equals minus 1 over, the same thing times the same thing, we just get x plus 1 when they are in square root. So square root of x plus 1 times square root of x plus 1 is just x plus 1. Now square root of x plus 1 plus square root of x plus 1 is telling us that they are double. So it's giving us 2 root x plus 1. So we are almost done. Let's clean here and conclude up. So finally, f prime of x will give us this times this minus 1 over, from the laws of indices, they have the same base and the power of this one here is just like half. Okay, so I can call it x plus 1 into 2 bracket x plus 1 power of half. Power of half. So since their powers are, their bases are the same thing, add their power. The power of this one is just like 1. So I have that f prime of x equals minus 1 over x plus 1. There is 2 here, so we shouldn't forget. Into 1 plus half, which is minus 1 all over 2 into x plus 1, then power of 3 over 2. Because when you add 1 plus half, you are getting 3 over 2. And that's just the solution, as simple as that.